Hello, everyone. My name is Haan, and I work at a place called Singularity University. It's a pleasure to be speaking with you here today at Slush. I'm incredibly impressed at such a gathering of people who've come together for this conference. I work in California at Singularity University on the NASA Ames Research Center campus. And today, I'm going to be talking with you trick question. I'm going to be talking with you about our mission at Singularity University, and I'm going to be explaining two underlying concepts that underpin everything that we do at Singularity University, and I'm going to talk about some implications of what we call exponential technology, and I'm going to make it an exciting announcement. This graph here is a logarithmic curve that shows how the power of computing, the same amount of computing that you can purchase for $1,000, has exponentially increased over the last 100 years. That's a logarithmic curve. You've all heard of Moore's Law. Well, prior to Moore's Law, this same exponential curve was in motion as far as computer processing speed is concerned. After what we have right now will be quantum computing, and this exponential curve will likely continue well into the future. One of our founders, Ray Kurzweil, is a futurist, and he looks at how these curves, where they end up, what becomes possible when you start to project 5 years, 10 years out into the future. And that's what we do at Singularity University. And that's not easy for us humans. If we go outside, if any one of us go outside and we take 30 steps, we'll roughly go 30 meters. If you take 30 exponential steps, meaning 1 is 1, 2 is 2, 3 is 4, 4 is 8, etc., you'll go around the Earth 26 times. That's the difference. That 30 meters versus going around the Earth 26 times is the difference between linear thinking and exponential thinking. Technology grows at an exponential rate. We're not used to thinking about that. We tend to look at the past to try to predict the future, but that's not the way it works. We see it with all the amazing technology that we have on display here at Slush, and it doesn't stop here. It continues in the future. And this is true for any technology which becomes an information technology. Artificial intelligence, robotics, biotechnology, nanotechnology, medicine, energy. All of these technologies are growing at exponential rates, and furthermore, they're converging. So people in the biotech world are interacting with people in the robotics world, are interacting with people in the nanotechnology world. Which means that when you start to project what's going to happen in the future, all kinds of new possibilities arise. And in fact, the future is already here for many of these technologies, such as driverless cars, such as making energy from algae, such as reading brain waves, etc. And it doesn't stop here, it continues. Exponential curves are deceptive. We're not used to thinking exponentially. We tend to think linearly, which is that black line. The exponential line is the red line. And at first, exponential curves are very slow. And they can be very disappointing, such as in the 1960s, people said, we're going to be having flying cars by now. Where's my flying car? Well, it so happens that last week, a flying car was just announced on the market. And 5 years from now, 10 years from now, we could all be driving around in flying cars. The difference is exponential curves start off slow and then they take off. We, right now, are witnessing the takeoff stage of a number of exponential technologies. Our other founder at Singularity University is a person named Peter Diamandis. He says, well, look at all these amazing exponential technologies, and look at all the world's problems. And if you start to apply exponential thinking to those challenges, you actually come to a world of abundance. We're used to thinking of problem after problem as intractable. But many of these challenges are solvable when one puts on an exponential lens. Peter's observation is that technology becomes, as soon as it becomes digitized, it becomes dematerialized. The phone you have in your pocket right now has the services of probably hundreds of devices that you had in the past. A video recorder, a camera, a computer, and many others. So it becomes dematerialized. It also becomes demonetized. Technology becomes cheaper and cheaper, as is on display in this conference as well. And very importantly, it becomes democratized, meaning people around the world not only have access to the technology, they have access to innovate with the technology. The price point to innovation and to being an entrepreneur and innovator is low. The barrier is no longer as it was in the past, where you had to be a large corporation to develop the next biggest thing. With exponential thinking and with abundance thinking, there are many implications. And I want to talk about 3 broad categories of implications with you today. One is on industry. The other one is on humanity's grand challenges. And lastly, society. Implications on industry. Industries are experiencing warp drive opportunities taken from Star Trek. Opportunities that are happening so fast, our organizations are pressed to keep pace with it. There's this concept of disrupt or be disrupted. If you're a large organization and if you're not purposely challenging yourself to disrupt your industry, you're likely to be disrupted by the next group of people who might just be 2 kids in a garage. And lastly, there's this concept of innovation at the edge. For large corporations to be able to innovate, in order to maintain their core business model, they should allow innovation at the edges. And when that innovation succeeds, to pivot their business model in that direction. But allow for those innovations to also fail. So warp drive opportunities. Conditions are now enabling billion-dollar companies in very short periods of time. IBM took 46 years to be a billion-dollar company. Google took 8, Facebook 5, Groupon 18 months. 18 months to become a billion-dollar company. And this is happening time and time again. WhatsApp is one of the latest ones, and who knows what the next one is going to happen in this conference here at Slush. Billion-dollar companies are being formed by small teams of people and disrupting large corporations. One example of that is what our founder, Peter Diamandis, likes to call the new Kodak moment. You all remember the Kodak advertising campaign, the Kodak moment. Well, the new Kodak moment concept is when a large corporation such as Kodak in 1996 had a $28 billion market cap, had nearly 150,000 employees, and their researchers developed the digital camera. But the executive team did not appreciate the exponential growth of that, meaning the digital camera pixel size would get much smaller and the price point would get much smaller. So they dismissed it. Well, by 2012, Kodak is near bankruptcy, market cap of less than $100 million, and only 17,000 employees. At the same time, Instagram shows up, has just 13 employees, and is sold for over $1 billion. This is the new reality of an economy working in exponential warp drive mode. Large corporations, and I don't even think I need to point it out here, in Finland, large corporations, if they're not prepared to anticipate the future and pivot fast, will be disrupted. And on the flip side, for entrepreneurs around the world, this creates whole new opportunities to succeed from a financial perspective and from a disrupting perspective. At Singularity University, however, we're not just interested in the implications for corporations and making lots of money. Our primary purpose is how exponential technology can be used to solve humanity's grand challenges. That's what makes us special. In the world today, roughly there's nearly 1 billion people who go to bed hungry, nearly 1 billion people who do not have access to clean water, nearly 1 billion people who do not have access to good health care, who are illiterate, etc. This is unacceptable. While we have great growth and large parts of our world thriving, to have other parts of our global community not is unacceptable. It's not viable, it's not moral, it's not good from an economic perspective, you name it. I personally live in parallel worlds. I work with famine-stricken people, and I advise startup companies that are making meat in petri dishes. We live in these two worlds. They're parallel worlds happening together on our planet. The overriding question that we ask anyone who comes into our programs at Singularity University is, how can you positively impact 1 billion people in the next 10 years? We issue that challenge to anyone who comes into our programs. And we frame it along what we call global grand challenges in food, education, healthcare, etc. So what are some implications on humanity's grand challenges? Number one, global challenges are local. We think of them as somewhere else, but in fact, they're local. The Ebola outbreak in West Africa affects us here, either because it's going to infect Finland, or it affects our travel, or it affects the global economy, or it affects the price of chocolate that you might like to eat because workers are not able to go and make chocolate. So global problems are local. Second is putting on an abundance mindset, not focusing on the problems per se, but on the solutions. Thirdly, something that we call system-centered design. Next is the great innovation transformation. And then opportunities for industry transformation. So the abundance mindset looks at something like water and says, okay, if all the water's resources are in that large blue circle and fresh water is in the small circle, that looks like a very scarce resource that we have to share on planet Earth. But if you look at the distribution of that, you'll see that 0.3% of that water is fresh water on the surface. That means that all the other water on the Earth, we're not using, we're not tapping into. That means whoever can solve desalination at a cheap price point and a cheap energy point has a huge opportunity waiting for them. Water is not a scarce resource, it's just not utilized in a way that's accessible to us now. Same thing for solar. 10 seconds of sunlight gives us a day of humanity's needs. 1 hour of sunlight gives us 1 year. The question is, how do we access it? What technologies can we use? One of the previous speakers mentioned that the price of solar has gone down 100-fold in the last 3 decades. And in the United States, it's reaching price parity with fossil fuels. The Great Innovation Challenge, a magazine called Foreign Policy, had this on their front cover: Can Silicon Valley save the world? Which really hits home to me, working in Silicon Valley and trying to save the world. And the answer is no. Silicon Valley can't save the world. And the reason why is twofold. One, technology-driven solutions oftentimes have no relevance for the places that they were best designed for or intended to be designed for. And two, Silicon Valley can't scale up. Innovators around the world are being empowered to come up with solutions themselves. We're introducing a concept called system-centered design. I don't have time to go through it with you. But one thing I do want to point out is this great innovation transformation. A book was just issued by Walter Isaacson, who wrote Steve Jobs' biography, and now he's written a book about the innovators. And it's a storyline of the people like Steve Jobs and Bill Gates who helped us create all this amazing technology. Well, the difference is the future will not be just in the hands of a few people. The power to innovate, the democratization of technology means that knowledge, access to technology, and capital through things like crowdfunding are increasingly in the hands of people around the world who are most experiencing the challenges. This will radically transform the way innovation is done. Just a couple weeks ago, I was in Argentina. In small rural schools in Argentina, they're learning how to make robots. So this isn't something that's unique to Helsinki or Silicon Valley. Everywhere in the world, innovators are being empowered to create things with technology. Also, in industry, there are many areas of transformation, which I do not have time to go into. Implications on society, I want to mention two. One are jobs. We have a lot of concerns at Singularity University about the implications of exponential technology on jobs. One study estimated that within the next 20 years, 46% of occupations as we know them will disappear. What this means for society, we do not know. Another one is a more existential question. None other than Elon Musk, about a week and a half, 2 weeks ago, went back to MIT, and he said that creating artificial intelligence is like unleashing the demons. Once they're out, they never go back. And will existentially challenge what it means to be human forever. We don't take a position at Singularity University about good or bad, but this is the kind of question we as a society need to be discussing. And we're definitely not having that discussion. Singularity University, we do education, innovation, and we have a community. In particular, we have something called a graduate studies program. It's a 10-week program, and we also have executive programs, 5-day programs. I was going to show you some examples of team projects. I do not have time because I want to I'm stuck. Oh, there we go. So we have something at Singularity University called a Global Impact Competition. And my exciting announcement is Finland will be hosting its very first Global Impact Competition. If I can get this. Right there. Finland will be hosting its very first Global Impact Competition to invite innovators throughout Finland to compete with their innovative ideas as to how they can help solve a challenge within Finland using exponential technology. And the winner, thanks to these sponsors, will get to come to Singularity University to be in our 10-week program. Yeah, thank you to those sponsors. I'd like to leave you with this thought from Buckminster Fuller. We're at a historic time when individuals can help shape our future. We all have that possibility and that responsibility. Thank you.